The question says find the derivative of 4x raised to 3 minus 2x plus 4 everything raised to the power of 5. This derivative is with respect to x. So let me attempt to answer that question. So copying the function, that is y equals to 4x raised to 3 minus 2x plus 4 everything raised to the power of 5. Looking at this function and think of the techniques or the rule you apply here. The nature of the function will tell you the type of techniques or the type of rule that we are going to use to find this derivative, because this is having power 5. Even if we are to expand it, we are going to have this brackets multiplied by itself 5 places, which will be very, very lengthy. So you have to employ a technique that will be simpler for you. The techniques that we apply here is the chain rule or composite rule. So to that, let me let inside the bracket to be u. This is the chain rule or the composite rule. So let me let inside the bracket to be u. So if I let u to be inside this bracket, so I'm going to have 4x raised to 3 minus 2x plus 4 is a function now u. So u is a new function in terms of x. So I can now rewrite this y. Y will now be equals to u raised to the power of 5. Because y is this bracket raised to the power of 5, and the bracket I let it to be u. So u is the bracket. So now I can rewrite the original function y in terms of u to be equals to y equals to u raised to the power of 5. Now I look at my formula or my rule. That is the composite rule or the chain rule. I need to find the du dx. I need to find the dy du. I have a function y in terms of u, which is this last one. So I'll find derivative of y with respect to u. That is going to be this one. And I have a function in the function u in terms of x. So I'll find the derivative of that function u with respect to x. So that is going to be this. Then I'll multiply. So let me do that. So I will now start with du dx. This is the function u. So I'm finding derivative of this with respect to x. This is the function u. So du dx, so it's going to be derivative of 4x raised to 3. Finding derivative, this power reduced, and that power multiply the present coefficient or the current coefficient. So I'm going to have 3 times 4 to get 12, and that power 3 reduced by 1. So I'm going to have 12x squared. Let me do that. So 12x squared minus 2. This is the derivative of minus 2x. This x is having power 1. So 1 will multiply 2 to get 2, and that power 1 reduced by 1. So change it to become power 0. And x power 0 is nothing but 1. So the du dx will be 12x squared minus 2. Derivative of 4. 4 is a constant value. Derivative of constant is always 0. So I continue. I will now find the dy du. So dy du, this is the function y in terms of u. So dy du, I'm finding derivative of y but with respect to u. This power 5 will multiply the coefficient here, which is 1. So 5 times 1 is 5, and the power 5 reduced by 1, so it become now power 4. So I'm going to have 5u raised to the power of 4. So I'm now good to go and substituting this formula. So I can now have my dy by dx to be equals to dy du, which is 5u raised to 4. So I substituted it, then multiplied by du dx, and du dx is 12x squared minus 2. So I'll continue. Let me now rearrange this somehow. So I'm going to have 5 times this bracket, then times u raised to 4. So that is what I'm doing next. So I'm having 5 multiplied by 12x squared minus 2. 12x squared minus 2 then multiplied by u raised to the power of 4. So next is to substitute u back, because u is already this function 4x raised to 3 minus 2x plus 4. So I'm going to take it back. So that gives me 5 into 12x squared minus 2, then times the bracket 4x raised to 3 minus 2x plus 4 raised to the power of 4. So this is where you stop. So to that I finish answering this very question. So what I'll just give you is the mark distribution for this according to the official Neco marking scheme. And this is the mark distribution. The very first mark is bonus 1 mark, and this bonus 1 mark is for getting dy du as 5u raised to 4. Next mark is for selecting the appropriate rule. In this case it is chain rule or composite rule. So selecting appropriate rule depending on the nature of function gives this method 1 mark. And the next, substituting in the rule, that is dy du and du dx, substituting them appropriately, you have this method 1 mark. And the last mark is the accuracy mark, when you have correct expression for dy by dx. So this is the final mark, accuracy 1 mark. So in total the question has 4 good marks.